Welcome to Cron Mastery. Let's start by stripping away the mystery and seeing what Cron actually is. At its core, Cron is just three things working together: a daemon that's always running in the background, a plain text file where you list your jobs, and a clock that ticks once every minute, forever, without you. By the end of this lesson, you'll know what Cron is, what a crontab is, how the two meet, and you'll have written your first real job, saved it, and watched it run. Before any theory, here are the 4 concrete skills you'll walk away with. First, identifying the cron daemon on any Linux box, telling cron, crond, vixie cron, and crony apart, and finding which one is actually running in about 10 seconds. Second, opening your own crontab and reading every line without flinching. Third, writing a real job, not a toy, that appends a time-stamped line to a log every minute. And fourth, verifying it actually ran by knowing exactly where to look when things go quiet. So before we touch a single command, let's anchor the mental model. Picture a quiet butler with a pocket watch. Every minute he glances at the watch, pulls a folded piece of paper from his pocket, that's your crontab, and reads it top to bottom. For every line where the time matches right now, he walks to the kitchen and runs that command. Then he folds the paper, puts it back, and waits 60 seconds. That's it. The butler is the croned daemon. The paper is your crontab file, and the watch ticks once a minute, never faster. Now let's meet that butler in the flesh. If you run PSF on any Linux box right now, you'll find him sitting there, usually as USR bias bin cron with the F flag, parented to PID1, running as root. He started at boot through a systemed unit, no one logged in to launch him. He wakes once every 60 seconds, costs you essentially 0 CPU, and quietly reads every crontab on the system. Yours, roots, and anything dropped into etc. checker cron.d. So if the daemon is the butler, the crontab is the folded piece of paper he reads. It lives at var spool crontabs, 1 file per user, but you never touch it directly. You run crontab E and the system handles the rest. Inside, the rules are refreshingly boring. Lines starting with dares are comments, blank lines are ignored, you can set a shell and a path at the top, and every real job is just 5 time fields followed by a command. That's the whole format. Now, what does that butler actually do, minute after minute? It's a 5-step loop, and the whole thing usually finishes in under 50 milliseconds. He wakes up when the OS scheduler taps him on the shoulder, rereads any crontab that's changed on disk, checks each job to see if the current time matches its 5 fields, forks a child process for every job that does, and then goes right back to sleep until the next minute ticks over. Wake, read, match, fork, sleep, and repeat forever. Enough theory. Let's prove this butler exists on your own machine. 3 commands, no editing yet. First, PSF piped through grep cron. If you see something like IUSR, SBIN cron, F, that's the daemon, alive and running in the foreground under systemed. Second, systemctl status cron confirms it from systemd's perspective. Active and running means up since boot. Enabled means it'll come back after a reboot. Third, crontab, L. On a fresh box, you'll get no crontab for your user. That's not an error. That's just the empty folded paper waiting for you to write on it in lesson 02. So why this design? Why a whole daemon for something so simple? 3 principles, and they're pure Unix. 1. Don't burn CPU asking, is it time yet? Cron wakes for about 50 milliseconds, checks the clock, and goes back to sleep. Roughly 1.2 seconds of CPU across an entire day. 2. The configuration is a plain text file you own. No web UI, no database, just something you can cat, diff, and back up with CP. And 3. When a job fires, cron forks a child, execs your command, and forgets about it. No queues, no retries, no babysitting. Cron's job ends at I started it. Everything after that is between you and your script. And that brings us here, the one slide worth printing. 3 columns mirroring the 3 things Cron actually is. On the left, every command you need to poke at the daemon. Is it running? Start it, enable it, read its log. In the middle, the crontab itself. List, edit, remove, and where the file actually lives on disk. And on the right, the loop's quiet rules. 1-minute resolution, reread every tick, system time zone, bin sh, and output goes to mail unless you redirect it. Tape this next to your monitor. You'll glance at it for a week, and then you won't need it anymore. Now, before we close out Lesson 1, 3 small exercises, and I mean it when I say don't skip them. First, find your daemon. Confirm Cron is running on your machine, get its PID, see which user owns it using PS, pgrep, and systemctl. Second, read the system log, last 20 lines from journalctl, and spot a job actually firing. Third, predict the future. Take that stand-up line, 9 in the morning, weekdays only, and write down by hand the next 5 times it would fire. 5 minutes of typing really does beat an hour of watching. And here's my gift to you. The 5 mistakes you're about to make anyway. Sudo crontab-e edits root's crontab, not yours. Editing the spool file directly, Cron won't notice. Expecting output in your terminal, it goes to the void. Redirect everything to a log file. Assuming home and path are set, they're not. Use absolute paths. And crontab-r, no confirmation, no undo, all your job's gone. Back up with crontab-l first. Always. And that's it. You now know what Cron actually is. A daemon called Cron, a text file called the crontab, a tick that beats every 60 seconds, and a process that runs as root. 4 facts, 1 mental model. In Lesson 02, we put it to work. You'll write your first job, watch it fire, and finally understand why 5 stars means it ran 60 times. See you in the next deck.